The main objective of today is to solve equations, and this is really a review for you guys. You did this for at least probably since 7th grade, maybe earlier. And the only difference though is that this is mostly story problems. The only thing is, most of the time in this section they give you the story problem, so it's they give you the equation, so it's pretty easy, but we're going to be reviewing it as we go. So the first example for today is looking at this Monopoly game. In the board game Monopoly, Boardwalk is the most expensive property. The one-time cost of the property is $1,400, while rent earned from another player landing on it is $2,000. If n equals the number of players landing on Boardwalk, then f of n equals 2,000 n minus 1,400 is the owner's total profit after n players have landed on the property. So what you're actually looking at is how much he paid for the property and how much rent he's earning. So you take the amount that you're earning minus what you pay. Okay? Okay, so if you will highlight that, that is what we're working with in this problem. So part A says, what is the owner's profit after 4 people land on Boardwalk? So it's asking really, what is f of 4? So simply just put it into the equation like you have been. Like such. If you calculate that, you will end up with $6,600. Part B asks, is it possible for the owner to make exactly $10,000 in profit? So this one's working backwards. It didn't tell you the number of people that landed, but it told you what the final outcome was. So this would be 10,000 equals 2,000 n minus 1,400. So we want to see if it's possible to get exactly 10,000. So what do you think I should do to solve for n? Okay, so yeah, we're going to add 1,400 to both sides. Okay, so then I have 11,400 equals 2,000 n. Now what? Divide it by 2,000. So that cancels out. And you should have an answer of n equals 5.7. We got an answer. You have a possible answer for n, but can you have 5 whole people and 0.7 of a person? No. So it's not possible to have that exact profit. So a lot of times in the real life problems that you're doing like this, you got to think, okay, I got an answer, but is that really a valid answer? Can I have a partial person? All right. So I want you to take the next minute to do the same thing for 2a. Okay, I'm going to pause this, and you guys can take time to do that. So A, you should have gotten for f of 1, $350. Is that what you guys got? Okay. For part B, the answer should have been n equals 14.32. So how many players do I have to get at least that much? 15. You round it up. Okay. So this has to round up to 15. So before we go on, I want to review what the distributive property is. And basically it's saying if you have something being added to each other with a multiple on the outside, you got to multiply each of the things on the inside. So I'm going to give you just a direct example of this. Say I have, and this is a really simple one, 5 times x plus 1. Okay, just to review. That means I want to multiply 5 times x plus 5 times 1. And that's the same thing as saying 5x plus 5. Darius has $500 to spend at a baseball card convention. He decided to spend all his money buying rookie cards of his 2 favorite players. So at the end of the season, Darius found that his first card increased in value by 21%, and while the second card decreased in value by 7%. He spent D dollars on the first card, so he spent $500 minus D dollars on the second card. Do you understand why they did that? Because he spent a total of $500 only on 2 players. So if he spent D amount on one, then it would be $500 minus D on the other. So hopefully that's clear. If Darius cards were worth $550 at the, oh, I skipped something here. So T of D equals 1.21 D. Do you understand why they did this? So it's adding in value. So if you have the whole value, so that would be 1 plus 0.21. 0.93 is 1 minus 0.07. That's how they got that one. Okay. So if Darius's cards were worth $550 at the end of the season, how much did he spend on each card? Okay, so we have $550. And that is going to be equal to the equation they gave us right here. So I'm just going to rewrite that. 1.21 D plus 0.93 times 500 minus D. So this is why I wanted to review distribution, because we now need to distribute that 0.93. I want to make sure that each of these get the 0.93. Okay, so we have 1.21 D plus 0.93 times 500. We have a minus here, so minus 0.93 times D. If you multiply that out, you will get 1.21 D plus 465 minus 0.93 D. All right, so we need to continue simplifying this, and I need to combine like terms. So I have a like term here and here. That will give me a 0.28 D plus 465 equals 550. What would I do next? Yep, subtract 465 from both sides. Okay, and if you do that, you end up with 35 over here equals 0.28. Oh, yeah, okay, 85. Sorry about that. Okay, and then what do I do next? Yep, divide this by 0.28. So D equals what? I couldn't hear you. What? 303.5. 0.57. Right? Okay? All right. So now, if he spent $303 on the one card, how much did he spend on the other card? Yep, 500 minus 303, right? So this is one card, and this is the other one. What is that amount? I don't have a calculator. Pardon me?
196.43.
Okay. That's the other card. All right. So, the same thought goes in part B. I want you guys to try that one now, and then we'll check your answers. Hopefully you got 25,000. Give you a second to look to see how I did it. So, yeah.
How did you get? Wouldn't you combine the .06 and the .04?
Okay, so remember we're going to distribute first. We have PEMDAS going on here. Okay, so if one of the cards was 25,000, what's the other one? I'm not cards, we're talking about inheritance. If one of the accounts is 25,000, what's the other account? It's also 25,000 because you'd take 50,000 minus 25,000. So both of them, he or she put in 25,000 in each account. Okay? All right, let's go on. We have clearing fractions and equations. How many of you like fractions in your algebra? Only a couple of you. Okay, I'm not surprised to see only a couple of you. I don't really enjoy having fractions, but there is a way to clear them out. Okay? So often in equation modeling, a real situation will involve fractions. And if you want to clear an equation of fractions, you are going to multiply each side of the equation by a common multiple of the denominators. All right? So, here we have an example, and they did not give us the equation on this. So, follow along with me. In Game 5 of 2006 NBA Finals between Miami and Dallas, Dirk Nowitzki, I can't say his name, scored 1/5 of Dallas's points, and Josh Howard scored 1/4 of Dallas's points. The rest of the Mavericks scored 55 points. So I'm going to call P the total of points scored. Okay? So if P is the total of points scored, I know that that's going to be equal to all the ones that Dirk scored plus Josh plus the rest of them. So if Dirk scored 1/5 of the total, it'll be 1/5 P plus 1/4 P for Josh plus the total that the rest of the team scored, which was 55. And what we want to know is how many total points were scored. Well, first of all, we got this beautiful fraction thing going on here. So how do I get rid of the fractions? What is the common denominator if I were to find one? Yes? 20. Because 5 times 4 is 20, right? So let's multiply the entire equation by 20. That means everything in there. Okay? So 20 times P is 20P. What is 1/5 of 20? Or 20 divided by 5? 4. Okay, and what is 20 divided by 4? 5. And then 20 times 55 is, yep, 1,100. Okay, so now we can do normal algebra and combine common numbers and then solve for p. So I already know that 4p plus 5p, that's going to be 9p. Right? Now, I need to get all the p's on one side. So I can subtract 9p. Then I will have 11p equals 1,100. So therefore, p must be 100. All right.